grade 12s. Let's have a look at question number 4 of the March 2025 Free State paper. Okay, so let's just get the cursor. Okay, so question number 4. You can see in the information provided already by the graphs given, and also you can see fx and gx, which we know is function notation. So we can see that we are going to be working with functions and inverses. Okay, so that's the first thing that you need to establish before you or when you start a question, is you have to see what this question is specifically about to go and highlight your formulas on the formula sheet. Now, we saw in question number 3 already that that was also functions and inverses, but that was the function of a parabola and its inverse, which is a root function, a square root function. But now we can see with this given information that we are going to be working with an exponential function and also a log function, okay? So, and we also know that this log function is the inverse of this exponential function. Okay, so we are going to be working with functions and inverses again, question number 4. So in this specific formula sheet, there weren't any formulas or principles on the formula sheet to assist you. So please remember that there's quite a lot of principles in this chapter in grade 12. So please make sure that this chapter specifically that you understand and that you study and memorize all of these principles and practice them as much as possible. Okay, so let's get going with the specific question. So they say in the diagram below, okay, so in the diagram, the graphs of fx equals 2 p to the power of x plus q and gx equals log x to the base t are given. Okay, so we know that we have, when we look at fx, guys, this is it's not explicitly stated, but we know this, okay? So we taught you in grade 10 already that just by looking at a specific standard formula of a specific function or the equation of the function, that you have to identify the function already. So we can see that fx is an exponential function, okay? So fx is an exponential function. That is what we can see. And the easiest way to see it is that x, our input value, that is a power, okay? So that is then an exponential function. We can see that 2p to the power of x plus q. Okay, so exponential function, and then also we have to know what this plus q stands for, because when they give us graphs and they give us formulas for specific functions or equations for specific functions, and there are unknowns in the functions, like for this exponential function, we can see that there's a p and a q. So we know that we're going to have to solve and solve these unknowns, okay? So your theory needs to, or comes in play over here. So for the plus q part, you know that that is your asymptote, okay? So the plus q part is your asymptote. And then please remember that it's your asymptote, this plus q part. Okay, so remember that is then where the graph never passes through, and that's where the graph never passes through or never touches. Okay, the asymptote. Okay. So that is what the plus q value is, and we can see on the sketch this line over here, this dotted line, that is then going to be our asymptote. Okay, then when we move over to gx, which is the log function, we can see that this is the standard log function with no extras. The only thing that they have in this function or in this equation is that you would see there that it's log x to the base t So that t is what we are going to have to solve in the log function. So we can already expect some questions over here to solve p, q, and t specifically. Okay, now let's read the rest of the information. So they say O represents the origin. So we know that O, where the y-axis and the x-axis, where they cross one another, that is where the origin is. We know that. They say the graphs have a common x-intercept at C. So they have a common x-intercept at C. So there is C. So it has a common x-intercept. Okay. So that means that G, my log function, has an x-intercept C. And F, my exponential function, also has an x-intercept, which is C. Okay. Then the graph of F has a y-intercept at D. So when we follow the graph of F, we would see that it has a y-intercept, which is coordinate D. Okay. Um, all of this is very basic, and we can see it on these on the graphs. But they have to explicitly tell us this, guys, because you would see that in the instructions, usually they say that graphs and sketches aren't always, and even diagrams aren't always sketched to scale. Okay, so they have to tell you these things. Okay. Um, the asymptote of f. Can you see now? We already told ourselves over here that the plus q value is the asymptote. And now that they talk about the asymptote, it's not something new we expected. So we are basically more comfortable with this information. So the asymptote of f, okay, which is this dotted line over here, okay? So the asymptote of f, all right, and the graph G both pass through the point A2 and -1. Okay, so my asymptote and G, can you see here where the asymptote, where the dotted line and G, where they meet, where they cross, that is where, or that's at point A, 2 and 1, 2 and -1. Okay. Then they say B is a point on F. So when we follow F, we first had D, which is the y-intercept. And then we had C, which is the x-intercept. And then when we go down, we would find here is B, which is a point on F. Okay, other than the two intercepts. Okay, and then this last one is very important. They say EBA is a line perpendicular to the x-axis and with E on the x-axis. Okay, so this is very important. Now, I'm going to show you what this means because quite a few students don't quite grasp what this last bullet means. Okay, so let's just explain. They talk about EBA, okay? So E, B, and A are all coordinates, and when you link them, it forms a line, okay? So there is E on the x-axis. When you go down, you would find B. When you go down, there is A. So when we connect EBA, it forms a straight line, okay? And they tell you that this line is perpendicular to the x-axis. Okay, there they draw you the 90-degree angle, which reminds you that this line is perpendicular. Okay, guys, so why would they give that information to us? All that this means is a perpendicular line to the x-axis just means that all the x values then for point E, point B, and point A, all the x values will be exactly the same. So we can go, we can see that our x value for A is 2. So that then means that the x value for B will be 2 and the x value for E will also be 2. So quickly, let's just go and do that. That's at least a starting point. So we know that the x value for E should be 2 based on the x value for A, but they tell us that E is on the x-axis, so we have the coordinate for E. which is 2 and 0. Then we go down to B. We know that the X value should be 2, okay, but we do not have the Y value. So we leave that Y. We will get to the Y value a bit later on. So guys, this is exactly what this last bullet means, okay? So if a line is perpendicular to the X axis, it just means that all coordinates, all points on that line have the same X value. Okay, so that is what we could have done with that information. So we are through all of the information. We know, let's just quickly follow F and G. Let's start with F, the exponential function. So we know that it has a horizontal asymptote, this plus Q value. So let's follow it. There F goes, the exponential function. Okay, so we know that D is the Y axis, C is the x-axis, B is an additional point on the line, but for that point, we still need the y value, and then you would see it goes closer and closer and closer to the asymptote, but it will never cross or touch this asymptote. Okay, then let's go to G, the function gx. So you would see that this is G, and when we follow it from the bottom up, we would see that the first point is point A, 2 and minus 1. And then we have the x-intercept, which is C, and then we go up all the way. And then we know then that the y-axis, remember that because the log function is the inverse of the exponential function, the log function will have a vertical asymptote. Okay, so the vertical asymptote for the log function is then the y-axis. As you can see, it moves closer and closer to the y-axis, but it will never touch or never cross the y-axis. Okay, because the y-axis is the asymptote for the log function. Okay, so now that we have all of that, we can start answering the questions. Okay, question 4.1. Okay, question 4.1. Determine the value of t in gx equals log x to the base t. So we need to solve for t. Now, when we look at this log function, or this equation for the log function, we need to go and solve t, right? So t is basically our only variable, okay? And we know that gx can be replaced by y, and x is then obviously x. So if we can get a y value and an x value to substitute in these two places, then t will be the only unknown. So the only way that we can replace y and x with values is by substituting a point, a specific coordinate into this equation. Okay, so that is the principle behind solving t. Now let's go and have a look. Do we have a point on G? There is G, yes. Can you see there? They gave us, they say G passes through point A. So we have point A that we can substitute into Gx to solve t. So let's go do that. So you are going to write what you're going to do. So you are going to say substitute. Okay. So substitute point A, okay, with the coordinates 2 and -1 into Gx. Okay. So that is your plan of action. So let's go and do that. So we are going to replace gx, which is my y value, right? Remember, gx represents my y value. We are going to replace the y with -1. So we are going to say -1 equals log. And then we are going to replace x with its value, which is 2. Okay, and then we need to solve the base of t. Okay, so this is what we have now. Can you see that we have everything is values except except t, which is the unknown that we need to solve. Okay, so now we know that we can rewrite this log equation into an exponential equation, okay? So we can do that by rewriting from right to left. Okay, that's what I teach my learners in this case, is you work from right to left to rewrite a log equation into an exponential equation. Okay, so we're first going to work with um, the 2, and then with the t, and then finally with the 1 to rewrite this log equation into an exponential equation. So this is how it works. So you are going to say 2 equals, okay, so t is the base in the log equation. T will remain the base in the exponential equation. And then what the log is equal to will be the power. Can you see we worked from from right to left to rewrite the log function into the the log equation into the exponential equation, okay? Because they are the inverses of one another. Okay, so now we can, there's more than one way to solve this, but let's go and get the power of t. Let's go make this to the power of -1. Let's go make this positive. And to do that, we need to take t below the line. It is grade 8 exponents. So we are going to say 2 equals 1 over t. Okay, to make the to make this power, this -1 power, to make it positive, we have to take t below the line. Okay, so now to isolate t, we need to get rid of this fraction, right? Because t is currently a denominator. So to get rid of a denominator, we need to multiply with the denominator. So we are going to multiply with t over here, and we are going to multiply with t over there. And then you would see that that t and that t would cancel, and then we have 2t on the left-hand side, and that would be equal to 1. And then it's very obvious that to isolate t, you have to divide by 2 for that 2 and that 2 to cancel. And then your final answer is t equals 1 over 2. Okay, so that is then your final answer. Now, I would suggest that you always, when you solve something, always go and reread your question to make sure that you have answered the question. So let's go back. They want the value of t. What did we give them? The value of t. So we definitely did answer this question, but t was the only unknown in my log functions equation. So we have to go and update our log functions equation. Okay. So we have to go and say, let's just go and update. We have to go and say, listen, this version is a bit outdated now. We have the latest version, which is gx equals log x to the base a half. Okay, so that is my final equation for my log function. So we can use this log function now to get x values, y values, and also please remember this principle as well. As soon as we have the final equation of a function, we can then also go and get the intercepts of that function. Okay, so in other words, we can get the intercept, the intercept now, because we have this the whole equation for the log function. We don't have the whole equation for the exponential function because we need to get a value for q and for p still before we can go and get this value of d, okay? Or to go and get this value of y for the specific point that is on f, okay? So please remember, this is also, it's small things, guys. So please remember that your brain realizes I did not just solve t, that is part of the function that is finalized now that I have solved t. Okay, so that was 4.1, guys, and that was definitely, it wasn't a difficult question. Substituting points, we teach you that from grade 10 already. Now let's move on to 4.2. So at 4.2, they say write down the coordinates of C. Okay, so I just told you that, right? C is the x um, intercept of both graphs. Okay, so we need to get the coordinates of C. Okay, and it is the x-intercept. When we go back up, can we see that C is the x-intercept of both graphs? But I cannot use the exponential function to calculate C. I need to use the log function to calculate C because I have its final equation. Okay, so we are going to use this log equation, or you would see it counts only 1 mark. Okay, and I'm going to tell you what that also means. So you can get the answer immediately. So because the log function, right, is the inverse of an exponential function, um, you would see that it has, and also because there's no plus q, you would see that this log function, the asymptote of this log function is the y-axis. We said that already over here, that the asymptote of g, of function g, is the y-axis. Okay, and then we also know that because it doesn't have a plus q value over here, that it would always go through 1 on the x-axis. Okay, perfect. So because basically there was no shift. Okay, um, yeah, there was no shift in this graph because there's no plus q value. Okay, so that then means automatically from the work that you had studied, you know then that this log function has to go through the x value 1. So we can already just go and we can go and say, listen, that we know that this has to be 1 and 0. Okay. We know that if an exponential function doesn't have this plus q, it would always go through 1. Remember, it can go this way or it can go that way. So because they are the inverses of one another, because an exponential function goes through a y value of 1, the log function will go through an x value of 1. And that is why we can say that C is 1 and 0. So you can go and write that answer immediately because it only counts 1 mark. So you can go and say, cool, C is 1 and 0. Okay, so that's definitely an easy mark. But I just quickly want to explain, I want to show you how to get to 1 if you maybe forgot this principle that without um, the plus q in your log equation, that your x intercept would be 1. If you forgot that, then you could have calculated, right? What do we know about an x-intercept? We know at the specific intercept, we know that the y would be equal to 0. So you can go and do that. You can use that principle then. So you can go and say, um, for an x-intercept, what do? We equate y to 0. Okay, so that's the principle that you could have used. And then you have to go and say, we have to go and replace y with 0. So it's going to be 0 equals log x to the base a half. So can you see we just replaced the y value with 0 in the equation gx, okay? Because that is how we get an x-intercept, okay? So now, once again, we want to rewrite this log equation into an exponential equation. And to do that, we have to go from right to left, okay? So we have to go from right to left to rewrite this log equation into an exponential equation. So therefore, we are going to say x equals my base in my log equation will also be my base in my exponential equation. And what the log is equal to will then be my power. So x equals a half to the power of 0, and then we know anything to the power of 0 equals 1. So can you see there is a way that you can prove that your x value should be 1. Okay, and then you could have written y has to be 0 and x has to be 1, so c equals 1 and 0. Okay, perfect. So let's move on to number 4.3. Okay, 4.3. What do they ask us to do over there? They say determine the value of P. Show all your workings for 3 marks. Okay, so we already knew when we had a look just now at this at fx, the exponential equation, we saw that there's a P and there's a Q. Okay, so now the question is that we have to go and solve for P. Now let's quickly think about this, right? We saw that they give us the asymptote over here. We just need to go and get the exact value of this asymptote, right? Because a horizontal line means a y value, right? Y equals something. Okay, and we can get that. They tell us over here that the asymptote passes through this point A. Okay, so at the specific point A, what is our y value? Our y value is -1. So that means that over here, obviously, that this line would also pass through -1. On this horizontal line, the y value remains -1. So by them telling us that this asymptote passes through this line, we know that this y value over here, this -1, would be the y value, basically the equation of this horizontal line. So y equals -1. Okay. So that is the equation of the asymptote, and that is also the value of Q then. Okay, so that's the first thing that you needed to do. You can replace the Q value with -1, and then we are moving closer, or then actually P would then be the only unknown, because we can replace Y and X with a specific coordinate on F, and then we can calculate the value of P. So let's quickly go and replace. Let's just go and update. We know that we are working with fx over here, and it's 2p to the power of x. Okay, 2p to the power of x. And then instead of plus q, we are going to replace that plus q with -1. Okay, we just saw that our asymptotes, the value of our asymptote is -1. So we go and replace that first. Okay, so always go and put in your asymptote first into your equation, and then you can go and solve for P. Now to solve for P, okay, because P is now the only unknown in this equation, we can substitute a coordinate on F, which will give me a y value and an x value, and then P would basically be the only variable or the only unknown. Okay, so let's go look at F. Now, when we follow F, because remember, we are looking now for a coordinate to substitute into F to get the value for P. So when we go down, we don't have D yet, but then you would see that point number C, coordinate C, we have this coordinate over here, which is 1 and 0. So we can substitute this coordinate into the exponential function, and then we can solve for P. So let's go ahead and do that. Okay, so you are then going to say that, listen, we are going to substitute point C, which is an x-intercept, so it's 1 and 0. We are going to substitute that into fx, okay? Because that's the only way that we can isolate P as the only variable, okay? So now let's do that. So we are going to replace y with 0. So we are going to say 0 equals 2p, and then we can replace the x with 1, 2p to the power of 1 minus 1. So can you see how simple this looks now? Because we replace the y value and the x value with the coordinates, and then we know that p to the power of 1 is just p, and then we can then take over this 1 to the left-hand side. So that means we have positive 1 on the left-hand side equals 2p, and then to isolate p, we just divide by 2, and we divide by 2, and obviously that then the answer for p is then a half. Okay, so that is how you get the value for p. So it's not that difficult, guys. The first thing that you do is you just put in your value of your asymptote, and then you substitute a coordinate, and then you get the value for p. Okay, so determine the value of p, show all your workings. We have the value of p. Here are our workings. So therefore, we have done this, and it is 3 marks. But remember that you just have to show yourself, right? You have to show yourself for the purposes of moving on with the next questions. You don't have to just always go and update what you have. So go and write your updated version of your exponential function, which is now 2, okay? And then we are going to replace p with its value, which is a half, okay, to the power of x, and then minus 1. So please remember that going forward, that this is now this equation for the function. This is now the final equation for the function. And now that you have the final equation for fx, you can go and calculate all the intercepts of f. Okay, and you would see that that is exactly what they ask in 4.4. Okay, that is what they then ask in 4.4. They say determine the coordinates of d for 2 marks. So when you move up, just quickly to remind yourself, what is the coordinates of d? The coordinates of d is the y-intercept of f. Okay, it's the y-intercept. And for a y-intercept, we know that we can go and say that x is then going to be 0. So that's what we can write in that intercept so long. We know that x has to be 0. Let's just go and get that then. So we have to go and say that, listen, in this updated equation for function f, okay, in this updated equation over here that we had just calculated, we need to go and replace the value of x with 0, and then we would get the value for y. So just stick to your basics. This is a principle. So you're going to say for a y-intercept, okay, what do? We replace x with 0. Okay, so let's do it. So you are going to say y equals 2 times a half to the power of 0 minus 1. Okay, so can you see we just replaced x, okay, with 0 to get the y value. All right. So now you would see that anything to the power of 0 is 1. Okay, so 2 times 1 will give me 2, and 2 minus 1 will give me 1. So then we have our y value is equal to 1. But once again, this is not your answer. You will not get 2 out of 2 if you only write y equals 1. Remember that they asked for the coordinates of d for 2 marks, and it's a green question. So you need to go and write it in this format. You have to go and say, therefore, the coordinates of d is 0 and 1. And then you go up to your graph and you go and update the coordinates, which is then 0 and 1. Okay, perfect. So now we have those 2 marks in the bag as well. Basic principles. And then we get to 4.5, which is calculate the length of AB. Okay, so they want the length, guys, of AB. So let's go and see where AB is exactly so that we can figure out how to calculate the length of AB. So AB is over here. Can you see there is point A? Let's just use another color because everything on this graph is green, or on this diagram is green. So they want the length of A. So this is where A is. Let's make that point orange. And then B, let's make that point orange as well so that we can see when we connect AB. This is what they are talking about, guys. When we connect AB, that is the length that they want, the length between A and B. Okay. Now, when we work with lengths on the Cartesian plane, okay, you have to ask yourself first, are we working with a vertical length or are we working with a horizontal length? And when you look at AB, we are working with a vertical length, okay? So for a vertical length, um, you always use your values on your y-axis, okay? Let me just make it make sense. So when you take this specific point, point B, the y value of point B, and you take it to your y axis, you would see that we already have the y value of point A, which is -1. Can you see? When we trace this back, you can see when we trace, we know that over here at on this point over here, point A, the y value is -1. So there we go. We already wrote -1 over here. So if we can figure out, that's why I'm tracing it to the y-axis for you. If we can figure out what this y value is, then we can get this vertical length over here, which would be the same as this vertical length over here. Okay, so do you understand the principle of why? When we work with a vertical length, you will work with your y axis. Okay, so basically what we need is we need this y value over here of coordinate number B. Okay, so that's basically what we're going to need to calculate this y value. All right, so to calculate this y value, we need to substitute x equal to 2 into our exponential function. Can you see that point B, coordinate B, lies on my exponential function? So we are going to substitute x with 2 in my exponential function. And then when we do that, we would get the y value where x is equal to 2. Okay, so let's go and do that. That is definitely the method behind the madness over here. So you can just use your function notation as well. You can go and say that in this graph, we are going to substitute the x value with 2. So therefore, or in this function, therefore it's going to be 2 times a half. Okay. And then remember, we need to replace the x value with 2, right? Okay, let's just go up. Can you see? We need to replace in our standard formula over here, we need to replace this x value with 2. Okay, so we are going to say a half to the power of 2 minus 1. So can you see now that when we get this answer over here, just type it into your calculator and get your answer. And then you will have the corresponding y value where x is equal to 2 in the function f. Okay, so when you say it's basically going to be 2 times a half to the power of 2 is a quarter, and then a quarter times 2 is a half, and then a half minus 1 is minus a half. Okay, so there you have your y value. It's minus a half, guys. You can just put that into your calculator and you would get minus a half. So let's go back up and let's go right. That this specific y value for coordinate B, the y value for coordinate B we know now is negative a half. So let's go and write that in. Okay. So this is then negative a half. So negative a half. Okay, so now that we have the y value of the coordinate b and the y value of coordinate a, we can go and see what the length is between a and b. Now, the rule to get a vertical length, guys, is to say you have to take your top y value and you have to subtract. You take your top y value and you subtract from it your bottom y value. So you're going to say negative a half, right? Minus 1. It's a principle that is in your book and that you please have to study. Okay, so to get a vertical length, you take your top y value, it's negative 1, minus your bottom y value, which is negative 1. So negative a half minus negative 1. Okay. Let's go and write that down. So it's basically going to be it's your top y value less your bottom y value to get a vertical length. So therefore, it's going to be to get AB, the length of AB. You're going to say the top y value is negative a half. From that, you're going to subtract, right? Subtract. And then you write your bottom y value, which is negative 1. Obviously, that negative and negative would give me a plus. So negative a half plus 1. So then the final answer for AB, when you say negative a half plus 1, is that the length of AB is half a unit. Okay. So that is the final answer, guys, to get the length. So it's very important to know that when you work with a vertical length, you need to work with y values of those two coordinates. And then you take the top y value minus the bottom y value to get your final answer. So this it's not going to be green. Let's make this one yellow. Okay. Now let's move on to 4.6. So at 4.6, they say write down the range of f. Okay, so the range. For only 1 mark, I'm going to make it yellow because I know that you guys struggle with domain and range. The first thing that you need to know is you have to understand that when they ask for range, they ask for y values. Okay, that's very important. So range is obviously the y values. Okay, so it's the y values. So you have to ask yourself, for which y values does my function exist? That is the one thing that you have to ask. So for range, you ask yourself, for which y values does my function exist? And for domain, you ask for which x values does my function exist? Okay. All right, so let's move on then. So we have to go look at y values. And f, remember, f is the exponential function, right? F is the exponential function. Now, the range of an exponential function is extremely easy. I always tell my learners, or I told them, that you have to go and look at the asymptotes. Okay, that is your answer. You have to go and look at your asymptote. What is the y value of your asymptote? And then that is going to be part of your answer. Now let's go up to the diagram to see logically, because yeah, you would understand logically when you see it now. So they are asking for the range of f. Okay, so I just told you, you have to ask yourself, for which y values does my graph exist? So my graph exists all the way up to infinity over here. Okay, then it goes all the way down. Okay, and then it crosses my y-axis. So all of these y values are applicable. Then it touches, and then it goes all the way down to the x-axis. So can you see that from 0 and above, okay, my graph definitely exists for all of these y values. Y equals 0 all the way to y equals positive infinity. This graph exists, okay? And then this graph goes below the x-axis, so into the negative y. Can you see it goes into the negative y, but it stops at the negative y. Can you see? It will never reach. It goes to negative y, but it will never reach y equals negative 1 because that is the asymptote. So the very easy answer that you have to write then is you look at your asymptote and you go and say, listen, um, my exponential function can never go lower than -1. So therefore, the answer is for my range is that the y values has to be greater than -1. Okay, can you see the y values? My exponential function doesn't exist um, at y values smaller than -1. Do you see that? So your y values, right, has to be greater than -1, cannot be equal to -1 because that's the asymptote. So the y values has to be greater than -1. So can you see over here, this part of the y-axis all the way up until positive infinity? Okay, so can you see? So please remember that when you answer range, you always look at your asymptote, and then depending on if it's above or below your asymptote, that is what your inequality will be. In this case, your y values have to be greater than the asymptote, and that is your answer. Y is greater than -1. Okay, so there we go. So y has to be greater than -1. So those are the y values for which my exponential function exists. Okay, then we move on to the last question of question number 4. And this is definitely, this is a pink question. So for those of you who aren't mathematically inclined, I'm telling you that this is a pink question. You don't necessarily have to pay attention to the explanation of these, but it's always a good thing to see maybe you understand what I'm talking about. Okay, so let's quickly unpack what they ask us to do over here. So determine the value or values of x. So guys, my final answer, they want values of x, right? So my final answer down here should be x equals something, okay? Or x or inequalities, of course, okay? Because we are working with inequalities over here given to us, okay? So it should be x equals or x smaller, greater, and equal to, or whatever the case may be. So that is what they ask over here, x values. Determine the values of x for which gx, guys, gx, we have to know with which function or with what function we are working over here. Okay, so we know that this is the, sorry, not the exponential function, this is the log function. Okay, so we are working with the log function over here. Okay, gx is the log function. So now that we know that, we can just go and replace. Guys, when you stare at this function notation of gx, you are going to make life difficult for yourself. When they ask questions like these, go and replace gx with y. Okay, go and replace gx with y because then it makes more sense. This gx just tells you with which function we are working. Okay, which function should you look at to get the x values for these specific y values. Okay, so let's have a look. We have to go to our log function and we have to see where on our log function is our y values greater and equal to -3/2. Guys, -3/2, you can actually go and just write it simpler for yourself. It is what we understand better is it's 1.5, 1.5 or 1.5. Okay, so this is what they are asking. Go to your log function and see where your y values are greater and equal than minus 1.5. And then where that is the case, please give me the x values for those specific y values of your graph as well. Okay. So the first thing that we're going to do is we're going to indicate on our graph where negative 1.5 lies. So let's go to our graph. Let's just make sure that we understand what is happening over here. Let's take blue for this question. So here we have negative 1, right? So we have negative 1. So negative 1.5 would be a bit below negative 1. So let's just go and estimate over here. Let's just do an estimate. So that over there, I would say is negative 3 over 2, negative 1.5. So we just went and said negative 1.5 so that we know in easier terms, it's 1.5. We know where that is. It's between negative 1 and negative 2. So there we have that. Okay. So now let's actually go and write this on the opposite side because I want to draw a dotted line. So negative 3 over 2. This is the blue. This is on the y axis. Now we have to go and see. Let's just quickly take this all the way to our log function. Now, there is where our y value of negative 3 over 2, that's where it will meet my log function. Okay, so we know that they ask us, right, for the x values where y is greater and equal than this blue dot. So where the y values are greater, which is up to positive infinity, and equal to negative 3. So can you see, basically, we want the x values for which g exists, right? So basically, we want the x values for this portion of g. Can you see? This portion of g over there. Can you see? Okay, not the this portion of g over here, because then this part of g will be will have y values which is lower than negative 3 over 2. So we don't want this, okay? So we want to have the x values for this blue part of my log function, okay? And for us to be able to do that, we need to also then get the x value when we are at this specific point. So we need to get that x value over there, okay? And to do that, we need to go and substitute. We need to go and substitute minus 3 over 2 into my log function, okay? So that we can get, so we know, sorry, that's not x, that's not x, that's not x. We know we need to get the x value at this specific point, but we have the y value, which is negative 3 over 2. So to get this x value, we need to substitute negative 3 over 2 into the log function. So that is going to be what we are going to do. So you are going to say substitute y equals negative 3 over 2 into gx, because we want the corresponding x value where y equals negative 3 over 2. Okay, so therefore we are going to say negative 3 over 2 equals log, remember it's in the log function, log x to the base a half. Okay, remember we just substituted y with negative 3 over 2 to get the specific x value to help us with our answer, because they want values for x. Okay, now to go and rewrite this log equation into an exponential equation, we need to work from right to left. So we are going to say x equals, remember, the base of my log equation will also be the base of my exponential equation, and it's going to be to the power of negative 3 over 2. Okay, guys, now you can just go and put your calculator. This is rational exponents. You can just go and say a half to the power of -3/2 and you will get your answer. Okay. In your calculator, which is then going to be, it could either be 2,83 or you could have left it in surd form, which is 2 root 2, 2 square root 2. Okay. But I just quickly want to show you something over here of how we get to this answer, because there are some very important principles that might come in handy, especially with trigonometry as well. So I'm referring to your roots, your root principles specifically. But let's have a look over here at how we do this ourselves. So what we can do without, if you did not use, or you should have used your calculator because you have to save time. I just want to explain without the calculator how you do this. Should there be other questions where you need these principles, these exponent or these laws of exponents, and then your surd laws as well. So the first thing that we would do is we would change this half because we can rewrite a half as 2 to the power of -1, right? That's the first thing that we would do. So we just rewrite the base of a half to 2 to the power of -1, okay? And then you would see that when we multiply, when we raise this power to the power of -3/2, we multiply these two powers, and then that would just make our power positive. So the answer of this would then be 2 to the power of 3/2, right? Okay. And then we know this principle over here that we are working here with a rational exponent. So the numerator is the root, which is going to be a square root, and the denominator of 2 is my root, which is a square root when it's a 2, and the numerator will then be the power under the root. Okay, these are principles that will never be on your formula sheet. Okay, it's in your book. Okay, so we can go and rewrite this then as, remember, it will be a square root due to your denominator of 2. Your base of 2 will be under the denominator, and your numerator of 3 would then be the power under your root. Okay, so when we get this answer, it would be the square root of 8. And now we are moving over to surd laws, which says that if we can rewrite this as 4 times 2, and then we know that the answer for, or the square root of 4 is 2, and then the 2 remains, and that is how you get 2 square root 2. Okay, so this is just for enrichment purposes, basically, for revision of your laws of exponents and some of your surd laws as well. Okay, so now that we have our x value of 2 square root 2, you can use 2,83 as well. Let's go back to our sketch to make sure that we understand what we are doing. So can you see now we have an x value over here of 2 square root 2. So over here it would be 2 square root 2. Okay, so now you can see that this blue section over here of my log function, this is the function of which, or the portion of the function of which I need the x values for my answer. So can you see now where this portion begins is at 2 square root 2. Can you see? So 2 square root 2, and then the y-axis is my asymptote for the log function. So x would never be equal to 0 because the equation of my y-axis is x equals 0. So therefore, it cannot be equal to 0, right? So my x values will be greater than 0, right? All the way up until equal to 2 square root 2. So my x values will lie over here. Okay, can you see that? Because for this x values, the blue portion of my function, exists. Okay, so my answer is then going to be that x, it has to be greater than 0. It cannot be equal to 0 because when x equals 0, it's my y-axis, and that's my asymptote. So that's why we only say x is greater than 0, but then x is smaller and equal to 2 square root 2. And then that is your final answer. Okay, so you would see that this question, basically, it was a quite easy question. They gave you enough green questions to not do too bad in this question. Okay, so only 4.5, 4.6, and 4.7 were a bit challenging. So yes, this was a very doable question. The next video will be question number 5, which is going to be trigonometry, which you would see that, in my opinion, that was the most difficult question of the paper, which had the most pink marks in it. Okay, so please keep studying. This is, you would see, you probably realize already how fast time flies in grade 12. So please keep studying, and this is for your own futures. Okay, so proud of all of you guys, and just keep pushing.